Introducing PX5 and the PX5 RTOS. We are all familiar with Linux, one of the most popular operating systems in the world, with over 3 billion users. Linux is used in desktop systems, development platforms, servers, and all sorts of other applications. For us in the embedded industry, embedded Linux is used in about 70% of the embedded designs, including smart TVs, routers, smart home devices, automotive infotainment systems, and more. For real-time multi-threaded embedded applications, embedded Linux includes the POSIX pthreads API, a standards-based interface to the services needed in such systems. The pthreads API is actually included in all embedded Linux distributions. So, as a result, most embedded developers are already at least familiar with pthreads, and many have used it in their development work and as a POSIX standard. It's beneficial for code reuse from project to project. Yes, why do we need a new RTOS if we already have pthreads for embedded Linux? The answer is that embedded Linux is not just ideal for all embedded applications. Most critically, hard real-time systems have very demanding interrupt response, context switching, and service call overhead requirements, usually sub-microsecond, and the faster, the better. On top of that, and making those performance issues even more difficult to address, embedded Linux has a relatively large memory footprint and a complex structure that requires MCU memory management hardware and ample CPU power to get through that complex code. Functionally, it's fine, but for performance and size, it's often not suitable. Then there are other possible complications, like a lack of professional support or legal issues that might make embedded Linux undesirable for a given application. Today's embedded industry offers many fine RTOS solutions that solve the performance, code size, support, and legal issues. And for those reasons, many are used in embedded devices that require high performance and small size. So why not use one of those? Because most, if not all, do not support the POSIX pthread API in a native form. Most have their own proprietary API, some good, some not so good, but none are compatible with pthreads. Legacy and interoperability requirements rule out recoding the API. There is a way to adapt them for use with pthreads through an adaptation layer. This translates pthreads API calls into comparable native RTOS functions. This presents a few challenges. First, an adaptation layer involves a significant amount of additional code for each service call. That extra code adds overhead that slows down the service's performance and also increases overall code size. Often, such an adaptation layer is developed independently with the RTOS, with different coding style, quality, or standards. And often, the compatibility isn't quite exactly what pthreads implies, meaning either extra code or an exception in compatibility. So what's the answer? How can the developers use the familiar POSIX standard pthreads API and still get hard real-time performance, small code size, and a sample, easy-to-use RTOS? Here's our answer. At PX5, our mission is to deliver the advantages of the industry-standard IEEE POSIX pthreads API found in Linux for use in hard real-time and resource-constrained embedded systems. That's what the PX5 RTOS is all about. It indeed uses POSIX pthreads API. PX5 is a native implementation of the pthreads API. That means it's not layered, enabling it to deliver sub-microsecond API service performance, sub-microsecond context switching, and deterministic real-time response. It achieves all this in an MCU-sized small memory footprint, as small as 1 kilobyte for minimal applications, and typically under 10 kilobytes for most applications, with as little as 1 kilobyte of RAM. PX5 is also designed for a simplified installation and use, on the order of a few minutes to install in most cases. As a result of how PX5 has been developed and optimized, it enhances your embedded development in a number of ways. PX5 achieves true RTOS performance in small size. While it's suitable for use in any platform, it's particularly valuable and well-suited for MCU-based systems, with constrained CPU and/or memory resources. PX5 enhances programmer productivity with its familiar standard API. PX5 enhances time to market and provides developers with industry-leading tools from IAR, ARM, and the Eclipse GCC community and quality, responsive, and accountable support. The bottom line is that PX5 enhances your ROI. PX5 also simplifies the development and deployment process. First, in learning and using PX5, by providing the familiar pthreads API, we also offer web-based learning tools like videos and white papers. And unlike many black box RTOS products, PX5 is delivered with well-documented full source code. Installation is simplified with our 3-step installation process that takes just a few minutes. PX5 simplifies development by managing the scheduling of application threads, and it's compatible with a wide range of popular development tools. The PX5 multi-threading structure simplifies customization of a project down the road, making addition of new threads, changes to priority, or other such enhancements simple to implement. Finally, PX5 simplifies support with direct, live, and email developer support from the same team that built the PX5 RTOS, and it knows it well enough to meet your every need. Not just bug fixing, but actual help in using PX5 for your application-specific needs. PX5 unites the popular, familiar IEEE POSIX standard pthreads API with the needs of the embedded systems industry. This API is familiar to the more than 70% of embedded developers who use embedded Linux today. PX5 unites this API with a native, hard real-time RTOS, small and simple enough for even resource-constrained MCU devices. All with full commercial licensing and expert technical support from our engineers. Beyond all that, we've designed and validated PX5 to be safe and secure. PX5 has been a 100% statement and branch condition tested and verified. Our unique pointer data verification (PDV) technology detects and helps prevent memory corruption. PX5 has completed clean static analysis of the entire codebase and is MISRA compliant with just a few exceptions. Next, in 2023, we plan to introduce IEC functional safety certification to the most common safety standards, including IEC 61508 and its industry-specific derivatives for medical, automotive, and industrial applications. PX5 is easy to use. We've made it easy to use to speed time to market. We've started with a familiar industry-standard pthreads API, no strange new API to learn and master. We've implemented an auto-convert tool to automatically convert your existing C main program to the system's first thread, making it simple and easy for you to go from there and add more threads as needed. We've made sure PX5 is compatible with development tools, compilers, debuggers, simulators from industry leaders like IAR and ARM, and the Eclipse GCC community. PX5 is delivered with an embedded user guide with examples, a demo application for getting started, as well as instructive tutorials, white papers, and videos. Finally, PX5 is delivered in full source code form for full visibility or source-level debuggers. Here's our PX5 business model. We start with a royalty-free commercial license with unlimited volume licensing, full developer indemnification from IP rights infringement, and a range of licensing models to suit product family and corporate-wide development. We also provide professional support free for the first 90 days and affordably priced thereafter. You'll get prompt response, unlimited calls, and 24/7 status availability with working hours, telephone, and email response. Here's how to get started. It's all there on our PX5 website, www.px5rtos.com. You can email us with questions, request for information, or a quote at info@px5rtos.com, or contact support at px5rtos.com. Or you can call us at 858-753-1715. Finally, check our website for information on upcoming webinars, and look for us at industry events in your area. Thank you for your interest in PX5.